what is the protocol behind them. Please recode it, okay? Please code it and you will get a better idea of how an SOC works. This is, I mean, somewhat like an SOC itself, right? But instead of
Yes.
EXI protocol, I have taken some basic protocols so that you can code it very easily. Okay.
I have one question about this. This is real quick. So about the valid and ready signal. It so we don't
Mhm.
we just have the signal on the interconnect, right? So uh,
On the DUT and between the DUT and the interconnect, DUT will give the ready, master will give the valid.
so which how can the slave know that it need to turn on assess the ready signal based on the
Okay.
address, right?
No,
Uh,
master, there can be many conditions. Either you can make your ready of the slave always high, okay? Either you can make ready of the slave always high, or whenever you sense the valid, whenever that slave is sensing the valid coming from the master side, it can assert its ready signal for one clock cycle.
so you
Sample
mean
the
that
valid.
the
Mhm.
so you mean that we have one ready signal and multiple valid signal?
No,
One valid signal and multiple ready signal.
no. Ready signal is the small line is the ready signal. It is per DUT. If this is duty is ready to accept the incoming valid, then it will raise it ready signal and sample the input.
So each DUT will have one ready signal, but on the interconnect,
Mhm.
it's only have one ready signal, right?
Interconnect, I mean, you're talking about this
Yeah, yes, ready signal.
to, towards the master side. Yeah, yeah. This
Oh,
will
yeah.
have one
So
ready signal. Yeah, like this.
okay.
So this will be stretched like this. Okay.
So so if we do this, we
Mm-hmm.
so if the ready is the indicate that the slave ready to get the to get the data from the master, but if we always assess the ready signal, how can the master know that that's
Master never waits for ready. In any of the protocol, master never waits for slave to be ready. It just asserts its valid signal and then wait for ready from the slave side.
yeah.
When the ready valid handshake will happen, okay, the master will drive its valid low after the handshake, after the next clock cycle, okay?
Uh, okay. So okay.
On line point 1, I have clearly written ready valid interface. Ready is coming from the slave, valid is from the master. Handshake occurs if ready valid both high on same clock cycles. Master should wait for ready before deasserting valid. Got it?
So in this case, the master don't know which slave will be assert the ready, right?
Why master should know? Master will send the address, right? If suppose master want to access this 2000, so it sends an address 2004. Okay,
So
so
it have okay.
master will make its valid high, this ready from the interconnect. Okay,
Uh,
whenever this interconnect sends the valid from the master is high, it will take this. Look, let me draw it for you. It would be much easy in that case. Okay, so let's talk it this way. Master suppose wants to access 2000. Okay, 2004. So which slave it is targeting? It is targeting this slave, right?
yes, sir.
So what master will do? Master will raise its valid signal. Okay, on the posage of the clock. Suppose this is the clock, and suppose ready is always high. For an example, ready is always high. Okay, so at this posage, ready valid handshake happened. So on the next pause age, the valid will get low. Okay.
Yes.
So ultimately, this is the process. And suppose second condition occurs when master sends the valid signal. Slave sense that okay, valid is coming, so it makes it ready high. Okay. And suppose this is the clock. So at this clock is ready and valid handshake happened. Okay, the slave can make its ready low, and master on the next clock cycle will make its ready low. Ultimately, on a single pauses, both ready and valid handshake should happen. That's I have written over here. Handshake occur if ready and valid both high on same clock cycle. Okay.
Yeah.
So if you want to target suppose 2000, so what will happen? Master will send the address with a valid signal. Interconnect will sample it. Now it's duty of the interconnect that what is the address, and depending upon the address, it will route the transaction to that particular slave, right? So it had routed the transaction to here. The valid of this interface will get high. The valid will get high. Okay. Then slave can. There are two conditions. Slave either the ready is always high, so slave will sample it, and on the next clock cycle, master will make it ready low. This indicates the transaction is completed.
So the interconnect also we need also implement the interconnect, right? This is,
Yes, yes. Everything need to be implemented. This is a scratch design. This is a raw design. So you need to implement everything. Usually, what happen in typical SOC, these arrows, blue arrows you are seeing, that these all are AXI interfaces.
yeah.
You need to implement everything what's been written over here. Okay.
Okay, sir. Okay.
Okay. So I think test bench creation we have completed, right? Test plan creation, test bench. We will talk about C environment setup and interaction between C and SV in today's class. Then we will talk about AXI attributes, back pressure, performance analysis. Okay. Sign off criteria we already discussed, right? Bug reporting tracking, I will explain you. So let's start with C environment setup and how the C code. That day I explained you in a basic way how. Okay, so that day we discussed about it, right? SRAM, uh,
Yeah, that's it.
okay, we use zir will write C code boot compile it to GCC compiler. C code is compiled hex. Yeah, we discussed about the C environment C example, right? And on the WhatsApp, I've also shared you about where is yours? Vietnam. So we discussed about this as well. So you read it?
Yes, sir.
Okay, so we discussed about the SOC environment, SV environment, and we are talking about the C-based environment. That how the C code is compiled. We use it through the GCC compiler. We compile it before starting of the simulation. When C code is compiled, OBJ ELF hex is generated. It is loaded backdoor from where we need to boot from. Stack location is also in SRAM. Boot manager is triggered by cold reset, and it will bring chip out of reset. Okay. When SRAM is resetted, we'll write backdoor hex to it in the reset phase. So everything, I mean, is clear for you, right? Base test is exiting. Ajit,
Yes.
booting is done. Base test is exiting. So, I mean, it's clear to you, right? So now we are discussing how to write the C code. अरे कुछ नहीं अजीत Okay, guys. So let's review this C code. So have you reviewed this C code? Anyone?
Yes, sir.
Yes, sir.
Okay. So I'll explain you 1 minute. Yeah, this is an example C code. Okay, it's much better over here. Okay. So basically, you guys know C and C++, right? Anyone here who don't know C and C++? Okay, so let's review it. Everyone knows C and C++. So the first file that we include is has include testcase.h. So this is a basic header file. Okay. Interrupt handler is written over here. So ISR means interrupt service routine that start over here. Okay. So everything is mentioned in the comment. Compare the interrupt ID triggered with your. Okay, let's leave it. First of all, we'll start with this. So usually we see this write and read functions, correct? Void register write CFG and void register read CFG. Okay, okay. So it's unsigned integer of 32-bit that is an input to this function. Okay, guys, and we are returning this value to ival. So when the input is coming, we give address. Pointer means the address. Okay. So what it will do? We have written volatile keyword over here. Volatile keyword explicitly means that we are targeting external memory and not cache. Okay. If we are writing volatile, then it means we need to store the data into a volatile memory. We are not targeting cache. We are targeting volatile memory. That so the transaction will be routed on the output interface of the CPU. So star rec pointer volatile. This is just and the irec pointer. So what will happen? The input address that you are giving. Okay, we are just taking that value in the pointer, and then what we are doing, this is the address, and star address means store this value on the address that's been mentioned inside this. Similarly, while reading it, what we are doing, we are just taking the address as an input. Okay, volatile star rec pointer equals to, we are just taking a local pointer over here and storing this value. Okay, so what in return rec pointer, so what it will do, it will go to this address. This is the address, and star means return the value what's been stored on this address. And volatile keyword, it means you are targeting external memory. So you know we have several registers inside an IP. Okay, so we have written register write CFG and register read CFG. So there are two functions. So what it will do, pad selected is the register name, and this is the value that we need to write into this register. So starting, okay, where is the main function? Void configure UART. So this is the function that we are calling. Config UART 0 processor main. So actual processor code starts from here. Processor main and starts here. It's been written. So we have taken an unsigned integer of 32-bit to read the data. Kick in it. So basically GIC we have studied about generic interrupt controller. So we need to do some basic programming of that GIC. So we have written a common function. Okay, to just program that gig. Okay, then there is another function to set the interrupt to gig that we are just wait for this 550 interrupt. Just wait for this 550 interrupt. This is a non-secure interrupt and the level triggered interrupt. Okay. So you will see that interrupt ID, route mode, priority, security, interrupt type, level or age. Okay. So this is a function that we are calling gig init. Below task configures the gig for interrupt ID of UART with its priority, security and type. Once it is done, we will now configure UART. So when UART is configured, the UART is a low speed peripheral, right? So the output of the UART has been connected to the pad. And you know pad have different functionalities. We already discussed about it. So suppose functionality 1 of the pad is connected to UART. So what we are doing, pad 8 and 9, we are programming it for functionality 1. Okay. Then we are just reading the data from pad select just to make sure that what value we had written is correct. Then we are using these two functions, write CFG and read CFG. Okay, so there is an UART control register and we are writing a value of 5. This value represents that, okay, we are just, enabling the UART and setting the TX bit of the UART.